All right, here we go. We're going to do a recap on 6.3 standard deviation because that wasn't well understood. What is standard deviation in your own words? Let's go with Connor. What do you remember? What is that? It is this distance away from me. Now, I wrote it up here. Okay, it's the average distance away from the mean. But if you had to just understand it, the mean is where everyone is. Yeah? You're asking, how far away from that mean are you? And the best way I showed it to you, or at least to the year 12s, this is what I showed them. I showed them two scenarios. And I said, if I predicted on average, that's your prediction, my prediction on average. This is the prediction, same line. The difference is when it comes to your exams, and I said, this is what I predict you guys would get, okay? And the data comes out like this. This is my class of 20 students. If I get a bunch of 20 students data for the exam at the end of the year, number of hours they study and what they actually get based on my prediction versus scenario 2. So if I asked you, which one of those two is a better prediction? Scenario 1, which is the top one, or is it scenario 2, the bottom one? Which one's a better predictor? Number 1. So you intuitively already understood what standard deviation is because what you did was you looked at my average prediction. Okay, my average prediction is never 100% correct. It's an average. That's what I'm predicting. And then your data, which is the green dots, what you guys actually get, how far away is it from my prediction? The closer it is to my prediction, the better it is. That's what we want. We want variation to be as small as possible. When you have such variety, then my prediction is poor. That's what standard deviation does. Standard deviation talks about how far away from the mean. And those two there, you intuitively already understood what standard deviation is. You may not know how to calculate it yet, but that's what these two formulas are doing. Last session, I spent too long trying to explain what the formula was. Forget about it. Let's just do it. Okay, now there are two types of formulas in the year 12 textbook. They're more specific. And if you do general as well, they can be specific as well. There's what we call population standard deviation, which just means how far is your data from the mean of the population, versus sample standard deviation just means how far is the data of the sample away from the mean. That's it. That's the only difference between the two. But the formula is slightly different. This is the only part that's different. If you have a sample, it's n minus 1. If you have a population, it's n. So what's the difference between population and sample? Population's like me saying the overall target audience. Sample is if you took only a few people from that group. So for example, year 12s, you guys don't represent all of the year 12s, but you are part of all of year 12s. So you're a sample of year 12s. If I wanted to get all the year 12s in Victoria, I would have to go to every single school, pull out all the year 12s and got them to line up here. That is a population. Get me? So population, then I would use n. But if I'm using just you guys, only 20 of you, I'd use 20 minus 1. So 20 minus 1 is the sample. Get me? So population is the overall, and that's the big-ass study data. Versus sample is easier to do. That's the only difference between the two. So if you're doing the exercises in the textbook, they tell you, is it a sample or is it a population? Then you just change that denominator. Okay? All right. Let's do an example. Let's say I gave you this one. You only got 4 pieces of data, 5, 6, 9, 20. You already know how to find the 5-number summary. So minimum, maximum, Q1, Q2, so the median, and then Q3. You know how to do that. How do you find the standard deviation? This is what you do. You need to first find the mean, because we said standard deviation has to be how far is it from the mean. So you need to know where the mean is. To find the mean, we already know, add all the numbers together and divide by number of numbers. Since I got 4 numbers, divide by 4. Let's add them together. 5 plus 6 plus 9 plus 20. Now 5 plus 6 gives you 11. 11 plus 9 is 20. And then 20 plus 20 must give you 40. And then 40 divided by 4 gives you 10. Okay, so we can all do that on a calculator, or you can do it on Excel. Doesn't matter. But you know the average now is 10. Okay, now notice the symbols I've got here in general and special and methods. That symbol there in Greek, it's mu, the mu symbol. That means population mean. X bar on your CAS calculators for those who do general, that means the sample mean. So if you ever, once you start doing the data stuff on your general stuff, that's the symbol difference between them. Okay. But in this case, I haven't told you where this population is sample, so I'm keeping it pretty open. But we know the mean is 10. So what I'm saying is that could have been the population mean, or it could have been this sample mean. Regardless, they're both 10. Cool? All right, so we found the mean. Now the next step of the formula, let's have a look at the formula. I found the mean. So here, I found the mean. I'm coloring it in. You've got the mean. What you're trying to find now is how far is your data from that mean. Okay, to find how far the data is, you take your data minus the mean. That's what it means. It just says, how far is it? Find the distance from your data to what I predicted you'd get. Data minus mean. Data minus mean. Yeah? What's the data? Well, I gave you this. I gave you 5, I gave you 6, I gave you 9, I gave you 20. What was the mean? The mean was 10. So each and every one of them, you are going to subtract it from the mean because you want to know how far it is. So I predicted this person would get 10 on average, but this person got 5. So 5 take away 10 tells me how far off I was. I'm 5 distance away, below, technically. Okay, so 5 below, 4 below. Now in this case, 9 minus 10 gives you -1. Very good. So I'm 1 below. So I'm 1 off. Okay, I said they're going to get 10, but they got 9. They're 1 below what I guessed. What about, they might have got 20, and I predicted they would get 10. So how far off am I? 10. Very good. Okay, so now, this is the distance. But in the formula, and I tried to explain last time, don't worry about the explanation now. This is the technique. Take these numbers and square them all. So on your calculator, -5 squared, or -5 times -5, gives you 25. -4 times -4 gives you 16. So that's -4 squared. Over here, we're going to do -1 squared, which just means -1 times -1. What does that give you? Not 2? No, 1. Okay, 1 times 1. You do 1 times 1, and then double negative is positive. But again, you got to calculate. Don't worry about it. Yeah? So -1 squared equals 1, and then same thing. 10 squared means 10 times 10. 10 times 10 is 100. Add them all together. Why do we add? Because the formula, see that symbol up here? This symbol right here is sigma. That's the symbol for sigma. Okay, and that means sum. So that means sum all of those numbers together. So here we go. I'm doing sigma. Add them all together. So I found the distance. I've squared them all. Here's my total. Okay, so what we've just done so far is this bit. In the formula on your sheet, if you have a look at it, we just did sum of the distance of your data to the mean, and you squared them. You squared them all, and you summed them all together. So 142 is a key number. That was the hardest bit. The last bit was literally just divide and square root. So here we go. Because we don't know if we have a population or a sample, the question should tell you. If it's a population, well, we've got 4 numbers. So we take 142 divided by 4. This will give us the population. This will eventually help us define population standard deviation. Whereas if you had a sample, if they told you it's a sample, then the only small difference you have to do is take the number of data you have minus 1. So that means you have 3. So that means here it'd be 142 divided by 3, which I don't know what that is. Let's do on a calculator here. 142 divided by 3. Write in 47.33. So 47.333. Okay, so what have we done in the formula so far? We've done sum all the squares. That was the key one. That's 142. And what's the next bit? We divided either by 4 or by 3. Now that we've done the inside, the last thing is just square root. Square root that answer. And mathematically, why do we do that? Because you squared it before. So you got to square root it to bring it back. Okay? Don't have to understand that. It's just the technique. Yeah? So, here we go. Last step. I've got 35.5. I've got a 47.333. Last step is square root each one. You have 5.9581. That's the standard deviation for the population because I'm square rooting this one. This is the standard deviation when I square root it, 6.87. That is the distance away from the mean. What does that mean visually? So if you had to visualize this, this is what it looks like. If you had your data group, in both scenarios, we're saying the average is 10. So most people sit at 10. The distance, how far you are from the mean, 6.8 this way and 6.8 that way. This is for the general students who do general. 6.8 this way and 6.8 that way. So if you add 10 plus 6.8 is 16.8, and then 10 minus 6.8 is like 3.2 or something like that. Okay? These two scores, if you do one step, I'm going to write this. Year 12s don't need to know this. No one needs to know this. Only for the general kids if they do. One step away from the mean is about 68% of you. Roughly. That's statistical. That if you do one step, one standard deviation to the left, one standard deviation to the right of the mean, you will cover 68% of the data in general. And you can do that realistically. In this class, if you did a survey, asked the number of siblings, and you did you actually calculated the data, and you tried this, 68% of you, roughly, in general, will fit that data. Whatever that number is that you come up with. Okay, so it's a really cool statistical fact, but that's all you need to know how to do. Does that make a bit more sense? Feel a bit more confident? Yeah? All right. Now, how could we have done this quicker? Because it is a long process, and the longest is this one. The more data you have, the more you subtract, the more you square, the more you add. That's where your mistakes will come in. Not these last two steps. It's that one. Okay, so this step's the longest. It's just knowing how to do. What's the quickest way? Literally, flip over the page, look at this step. There's only two things you have to enter. You type in the data, which I'll show you, I'll demonstrate it to you. I'll type in 5, 6, 9, 20 in one column. And you just need to find, is the standard deviation .p? So stdev.p, if you type that in, it either calculates population standard deviation or sample standard deviation. So here we go. I'll show you how it looks. If you go on Excel, where's Excel? I'm just going to do Excel. Here we go. Simple Excel stuff. Here we go. Let's enter the numbers. We got 5 plus 6, 9, and 20. If you want to find the population standard deviation, you always have to type equals to enter a code. STDEV. And it's already got templates for you. You've got .p or .s. .p is population. .s is sample. So I'm going to do .p bracket. And here we go. I just want 5 to 20. Or you can type in A1 to A4, depending which cells you put in. Close the brackets. That was the answer you got too. 5.95 roughly. If I want to do the sample population, it'll be equals stdev.s, open brackets, highlight that, close brackets, and that's what we got too, 6.8. That's the quickest way to do it, and realistically, that's probably how people in the real world would do it, rather than the CAS. So if you're doing it in general will teach you how to do it with the CAS. This one is for you guys if you're doing the exercise 6.3. You want a quick way, probably do it through Excel. Otherwise, you can practice it manually. Realistically, no one does it manually in the real world. Okay, but theoretically, you need to understand how to do it. Cool? That's 6.3. So you got this session to have a look, practice those skills. I'll be going through OneNote, just double checking those who submitted their work and who hasn't, and skills that I'm unsure about, call you up. Tomorrow I am doing a quiz for chapter 5 and a bit of what you did before about IQR, mean, median, 5 number summary. So tomorrow there's a quiz that runs about maybe 30 minutes. I just want to get a vibe on what skills you've learnt so far. Okay, so leading up to the SAC, I need to know that you can calculate data, read data, construct data. Cool? All right, I'm going to stop the video there.